Dear students, welcome to today's online class. Just 5 minutes late for some disturbance. Yesterday we discussed about the P block elements and the basic characteristics of 15th group elements. So we discussed about the electronic configuration of 15th group element, its ionization enthalpy, electronegativity, and electron gain enthalpy. So today we shall continue our discussion on other characteristics. See, 15 group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. As you come down the group, atomic and ionic size increases. Along the period, ionization enthalpy increases. See, ionization enthalpy as you come down the group, it also decreases. Electronegativity decreases. Electron gain enthalpy also decreases. So this much we discussed, and even we discussed why nitrogen is anomalous. Nitrogen is anomalous with other elements of 15th group. It is due to small size, high electronegativity, high ionization enthalpy, and unavailability of d orbital. At least 3 points you have to write. Okay, next part you have to study about oxidation state of 15th group elements. Oxidation state. Oxidation state. The general oxidation state shown by these group elements are, see, -3, +3, and +5. These are the stable oxidation state shown by 15 group elements. Nitrogen can show variable oxidation state, but as you come down the group, the negative oxidation state decreases and positive oxidation state increases. See, as you come down again, arsenic, antimony, bismuth, again +3 oxidation state increases. It is due to inert matter. So different oxides of nitrogen: NO, nitric oxide, nitrogen dioxide, NO2, N2O4, N2O3, N2O5. From all these oxides, nitrogen shows variable oxidation state. We can find in nitrogen +1, +2, +3, even +4. If you go for lower elements below, then stable oxidation state is plus 3 or plus 5. If you go for nitrogen again, due to its covalency, see beyond 4, that means 5 or 6 covalency is not possible for nitrogen. Are you clear? See some disturbance. I think A class students link is not sent. We'll see. Okay. Okay, that is nothing but oxidation state. See, then we have to study why these oxidation states are stable. See, it is due to the valency electron. In the nitrogen, you go for phosphorus, arsenic, and antimony. So, availability of 3D, 4D, and even 4F orbitals. 4 covalency is possible. For nitrogen in second group, so its covalence is only 4 due to the presence of 2s and 2p orbital. Okay. After the oxidation state, we have to study the reaction of these elements, that is nitrogen, phosphorus, arsenic, antimony, bismuth. Its reactivity towards hydrogen. How it reacts with hydrogen. See, all 15 group elements react with hydrogen and it forms the stable hydrides of type EH3. See, stable where E is an alien. See, if it combines with nitrogen, you will get NH3, which is ammonia, PH3, arsenic H3, antimony H3. And bismuth H. See, these stable hydrides are formed. You have to compare different properties of these hydrides. Hydrogen reacts with 15 group elements and it forms its hydrides, trihydrides. Those are NH3, PH3, AS, arsenic hydride, antimony hydride, and bismuth hydride. Among these, you have to study some characteristics. See, what are those characteristics? Those are acidic properties. See, nitrogen, from as you come down about these hydrides, this bismuth hydride is more acidic. So, acidic strength increases as follows. So this is the difference. See, this is the increasing order of their acidic strength. Whatever is stability, we shall go for its stability. So first you study acidic strength and then stability. See, as ammonia, phosphorus trihydride. If you go here, as size increases of these atoms, and according to its stability, ammonia is more stable. The hydride of nitrogen is more stable because it forms by a hydrogen bond. We cannot find any hydrogen bond here. See, as you compare, which is stable, whether ammonia or arsenic hydride or bismuth hydride? No, more stable is Echo it will be. Just open the door. Okay. About the stability, which is more stable here? Ammonia is more stable than other hydrogens. It is stable. Ammonia forms hydrogen bond with hydrogen and nitrogen atom, which is more electronegative. So hydrogen forms in its molecule and hydrogen bond. So therefore ammonia is more stable than other hydrogens. Okay, stability increases in this reverse order. We will study two concepts. One is acidic strength. Acidic strength increases as follows. Acidic strength is lower in ammonia and higher in bismuth hydride. If you go for stability, among these, ammonia is more stable and these are less stable. Then we go for the basic character. Basic. See, basic character is, you know already ammonia is highly basic. So basic character increases as follows. See, in reverse order. So basic strength increases. So ammonia is highly basic than other hydrides of base. If you go for reducing agent, reducing nature, which is material can easily oxidize. So bismuth hydride, so reducing agent is a reverse one. So bismuth hydride is highly reducing agent because it can easily oxidize. Are you clear? Okay. So we have to compare these hydrides regarding its acidic strength, stability, then basicity and reducing character. So sometimes you will get one more question in CET, one question can also appear. You have to arrange in increasing order or decreasing order. Okay, I will repeat again. See, when 15 group elements reacts with hydrogen, it forms see EH3 type of hydrides. Those are NH3, PH3, ASH3, SPH3 and BRH3. You have to compare certain properties. What are those properties you have to compare? Its stability, its acidic character, its basic character and its reducing character. So reducing character increases, basic character increases like this, and acidic character in the reverse order. You can easily understand. Okay. So this is going to be the reaction with hydrogen. Next we shall study the reaction with oxygen. How these 15 group elements reacts with oxygen. 15 group elements reacts with oxygen and forms two types of oxides. Those are of type E2O3 and E2O5. Trioxides and pentoxides. Where E is on the edges of the 15. It was two types of oxides. And see, E2O3 lower oxides are acidic in nature. All these oxides. See, you know general trend, non-metallic oxides are acidic in nature. So E2O5, these are more covalent. So it forms two types of oxides. One is E2O3 and another one is E2O5. See this E2O3, all these are major majority, they are acidic in nature except bismuth. So bismuth oxides are basic in nature. Because it is a metal, you know, metal oxides are basic in nature. non-metal oxides are acidic in nature. That is a general trend which you remember. You studied in first page. Are you clear? Remember, it forms two types of oxide. One is E2O3 and E2O5. Are you clear? Where is the all these elements? You can easily write. Remember, all the oxides are what? All these oxides generally they are acidic in nature. If you go for arsenic and antimony oxide, they are amphoteric in nature. Generally, we will call this as they are acidic oxide. No. Antimony and bismuth, which is nothing but a metal, right? Those metalloid oxides are amphoteric in nature. So we can find three types of oxides: acidic oxides, basic oxide, which is nothing but bismuth oxide, and also amphoteric oxides. So amphoteric oxides, the oxides of arsenic and antimony. So generally we will call these non-metallic oxides are acidic in nature. Now, due to the difference in their physical properties, metal and non-metal, so we can find these two types of oxides. But nitrogen forms variable oxidation state, so it forms different oxides: nitric oxide, nitrogen dioxide, nitrogen pentoxide. So this is nothing but the reactivity of 15 with oxygen. Okay, we shall study next with the halogens, with halogens, with halogens, with the halogens. See, these 15 group elements react with halogens and they form see EX3 and EX5 types of halides. Are you clear? Again, it also forms two types of halides. Where X is a halogenate, it may be chlorine, chlorine, bromine, iron. Are you clear? The 15 group elements reacts with halogen and forms two types of halides. So those are, take for example, see PCl3 and PCl5. So higher covalent compounds, they are more covalent. The higher halogen compounds, PCl is more covalent than the trihalides. That point you have to take. Are you clear? So it reacts with halogen and forms two types of halides. So those are trihalides as well as pentahalides. Among them, pentahalides are more covalent. Pentahalides are more covalent. To study in first page the detailed structure of phosphorus pentachlorid. Okay, these are nothing but reaction with halogens. And we have to study last week metals. So these elements, 15 group elements, reacts with metals and forms metal nitrides. Take for example, it reacts with lithium. For example, take for example nitrogen, and you will get lithium nitride. You can balance the equation. Say 6 lithium Cn2, and you will get 2 Li3N. Are you clear? It reacts with metal, an alkali metal, so it forms lithium nitride. Like that, all the elements reacts with all the 15 group elements react with metals and it forms metal nitrides. These metal nitrides you can easily write. Okay, again it reacts with the covalent, which is the non-metal also. There also it forms a covalent. Okay, you study reaction with hydrogen, reaction with oxygen, then reaction with halogen and reaction with metals. So this is nothing but the basic of 15 group elements, particularly of 15 group elements. Next we have to study. Dinitrogen, which is nothing but a compound of 15 group elements, dinitrogen gas. Nitrogen gas. Generally we call nitrogen. So you know occurrence of nitrogen. So nitrogen comprises nearly 78% of our universe. So nitrogen, which is a diatomic, which is colorless, odorless, non-toxic gas. We have to study some preparation, its important chemical reaction. The compounds of 15 group, the first compound, which is nothing but then we have to study compound ammonia also. So first we shall discuss about dinitrogen. So dinitrogen, which is a colorless, odorless, non-toxic gas. See, it is stable at room temperature. It is stable at room temperature because its bond dissociation enthalpy is low. So you on molecular orbital theory you studied nitrogen to nitrogen triple bond. In first way you studied molecular orbital theory. So we can find triple bond as bond dissociation enthalpy is more, so it is stable at room temperature. See, at a high temperature, so it can decompose. Okay, so this is the basic thing we have to remember about nitrogen. So, how nitrogen gas can be prepared? It can be prepared by the reaction between ammonium chloride and sodium nitride. Sodium nitride. Na, sodium nitride. NaNO3. So we will get the equation. So N2 gas plus 2H2O plus NaCl. So here sodium nitride NaNO2. Not NO2, nitrate. Nitrate is NO3. Nitrite is NO2. Sodium nitride. Reaction with ammonium chloride, aqueous. You will get nitrogen gas. So how dinitrogen gas is prepared? It is prepared by the reaction between aqueous ammonium chloride and sodium nitride to form nitrogen gas. Simple equation. So it can also be prepared by the thermal decomposition of ammonium dichromate. It can also be prepared by the thermal decomposition of ammonium nitrate. So what is the formula of ammonium nitrate? NH4 twice Cr2O7. See, ammonium nitrate, which thermally decomposes at high temperature. So you will get 2 NH3 plus Cr2O3 and plus 2 H2O. So here you can balance only thermal decomposition of ammonium nitrate. So you will get N2, then Cr2O3 plus 4H2. Concentrate on equation. Ammonium dichromate on thermal decomposition will get dinitrogen gas, then chromic oxide and water. See, just to balance it, 8 hydrogen atom and then also 8 hydrogen atom, oxygen totally 7. By writing the equation, just check the atoms on both the sides, you can easily balance. So we will get nitrogen gas. I'll repeat again. So thermal decomposition of ammonium dichromate. So ammonium dichromate thermally decomposes at high temperature to form nitrogen gas along with chromic oxide and water molecule will be. So therefore, this is the second method of preparation. And third method, which is nothing but the preparation of pure dinitrogen. So again, it is by the decomposition of barium azide or sodium azide. Barium, Ba, N2 thrice. So we will get barium plus 3 N2. So which is nothing but a pure dinitrogen gas preparation by barium azide. So you will get in notes all the equation. Don't worry. But remember the preparation of nitrogen gas. Dinitrogen gas can be prepared by the reaction between aqueous solution of ammonium chloride and sodium nitrite. So you will get nitrogen gas. In second method of preparation, thermal decomposition of ammonium dichromate. In thermal decomposition of ammonium dichromate, you will get dinitrogen gas. Again, pure dinitrogen gas can be prepared again by the decomposition of barium azide. Barium azide. So this equation I will give you notes. Just you can refer. This is nothing but important preparation of dinitrogen gas. So we shall study some of the chemical properties of dinitrogen gas. So what about its physical property? You know it is nothing but a non-toxic, colorless, odorless gas. We studied in biology nitrogen cycle. Okay. So what are its important chemical reactions? See, at a high temperature, this nitrogen gas reacts with oxygen gas, and we'll get nitric oxide. So at a high temperature, nearly more than 1500 Kelvin, nitric oxide is formed. It is available in the gaseous state, it is also in gaseous state, and it is also a Are you clear? So this again another important thing again how to study nitrogen gas reacts with hydrogen gas, and we will get ammonia. Again you have to study in detail the compound of the chemical ammonia. So again drastic condition is required at high temperature. We have to use the catalyst and we have to apply the pressure. So these are the important reactions which you have to remember for dinitrogen gas. Are you clear? So nitrogen reacts with oxygen gas to form nitric oxide. Then again dinitrogen reacts with dihydrogen gas. We will get ammonia. We shall study ammonia in detail in the compound of ammonia in next one. Are you clear? So we studied about dinitrogen gas. It's important preparation. According to the syllabus, you have to study 3 preparations. Chemical equations are there. You have to practice the chemical equation. And in its reaction, chemical reactivity, dinitrogen reacts with oxygen, we will get nitric oxide. And again, in dinitrogen gas reacts with dihydrogen gas, ammonia is formed. Okay. What are the uses of dinitrogen? So it is used as a refrigerant. Ammonia is it's dinitrogen gas, and again it is in the atmosphere for the plants, and they will receive this atomic nitrogen. How nitrogen cycle is balanced? See, in earth crust, in the soil, pseudomonas, nitrosomonas, bacteria are there. The nitrates are converted into atomic molecular nitrogen in the atmosphere, so that nitrogen cycle continues. So that is nothing but dinitrogen gas. Now we shall study another important compound, which is nothing but ammonia. Ammonia. So the formula for ammonia is H3. See, you have to study according to your syllabus. Preparation of ammonia by Haber process. First, I will discuss that one only, and some other methods are there for the preparation of ammonia. We shall discuss preparation of ammonia by Haber's process. Some points we have to remember. See, pure dinitrogen gas reacts with pure dihydrogen gas. The pure dinitrogen gas is obtained from fractional distillation of air, and hydrogen is obtained from the water and made to react in a compressor with a high pressure, nearly 200 atm pressure or 200 into 10 raised to 5 Pascal pressure. So this dinitrogen and dioxygen is made to react at a high temperature, nearly at 700 Kelvin, and in the presence of catalyst, finely powdered iron oxide, along with the promoter, potassium oxide A2 and Al2O3, aluminum oxide. See, this drastic condition should be maintained. Then in a catalytic converter, this dinitrogen and dihydrogen reacts together and forms ammonia. So ammonia formation is very less, nearly 10 to 15%, because see, dinitrogen and dihydrogen gas, even in this drastic condition, they won't react. There is no proper orientation, as both the molecules are in smaller size. So drastic condition should be maintained. So according to the syllabus, you have to study one flow chart and chemical equation. You have to write the flow chart, and particularly you can just see in any annual examination how ammonia can be prepared by Haber process, what are the drastic conditions, or draw a flow chart for the preparation of ammonia. So I will repeat again how ammonia is manufactured by Haber process. Dinitrogen gas reacts with dihydrogen gas to form ammonia. We have to write the equation. The relevant equation is N2 gas plus 3H2 gas, and it is nothing but a reversible reaction. We will get 2NH3 gas. Clear? Ammonia is obtained. So, enthalpy of this reaction will delta H equal to minus 46.1 kilojoule per mole. What are the drastic conditions here? Say this dinitrogen and dihydrogen does not react. So therefore we have to apply drastic conditions. A pressure of 200 atmosphere, a temperature of 700 Kelvin, even though it is an exothermic reaction. So in a catalytic chamber it requires a temperature. And again catalyst, FeO as a catalyst, and to increase its catalytic activity it has to add certain chemical which is called A2O plus Al2O3, which is called promoter. Okay, we shall have the flow chart of preparation of ammonia by Haber process. We shall study its flow chart. See the pure dinitrogen and pure dihydrogen gas is passed through the strong pipes, and these are connected to the compressor. So this is nothing but the compressor where high pressure is applied, nearly 200 atm pressure. So this dinitrogen gas and dihydrogen gas is passed. We have a rough sketch. And this is passed through a catalytic chain. It is passed through a catalytic chain. So this is nothing but a catalytic chamber. It is nothing but a catalytic chamber. So name the catalyst here. So catalyst is FeO along with K2O and Al2O3. So these are promoters, and this is nothing but the catalyst. And this is nothing but a catalytic converter. What is the temperature required here? Nearly 700 Kelvin temperature. Nearly 700 Kelvin temperature. So dinitrogen gas reacts with dihydrogen gas in catalytic chamber, and ammonia is going to form. Ammonia is going to form. So this is nothing but the condenser where ammonia is correct. So this is nothing but the condenser. So we can find liquid ammonia here. On compressor, we get liquid ammonia. And whatever the unreacted gas, I already told you, only 10 to 20% ammonia we can get by this process. And it contains large amount of unreacted nitrogen and hydrogen gas. So again you have to transfer this in the recycle pump. So this is nothing but a recycle pump. So this is nothing but a recycle pump. You have to add this. This is nothing but a recycle pump. Okay, so it is nothing but a recycle pump. And whatever the gas which is unreacted, it passes and again it enters in the catalytic chain. Thus, ammonia is prepared by Haber process. Are you clear? Okay. Dinitrogen, pure dinitrogen, if the gas is impure, it poisons the catalytic chain. So therefore, whatever the nitrogen and hydrogen you are going to pass in a chamber, it should be very pure. While fractional distillation of air, or how we will get hydrogen even by water also we can get hydrogen. So that should be very pure. And this pure dihydrogen and dioxide gas is passed into a compressor, which contains reduce the pressure and make to react. See, 200 atm pressure, very high pressure. Converted into Pascal 200 into 10⁵ Pascal pressure. And in the catalytic chamber, actual reaction takes place. Dinitrogen reacts with dihydrogen. You have to remember, how to remember the drastic condition. Again and again, repeatedly write the equation and remember the condition. Without the drastic condition, it is impossible to prepare ammonia. What are those drastic conditions? Temperature is nearly 700 Kelvin. Catalyst used is iron oxide along with promoter K2 and aluminium oxide, and a pressure of 200 atmosphere atm. These are the three important drastic conditions. So sometimes in annual examination you will get the question, how ammonia is prepared by Haber process, right? Chemical equation, temperature required, name the catalyst and the promoter used. And this much you have to write. Whatever is, you have to write. Explain by a flow chart. You have to explain. Are you clear? So today we discussed about preparation of ammonia by Haber process. In first phase only I told about the scientist Haber, his history, you know all. Okay? Here I will repeat again. Dihydrogen reacts with dihydrogen and we will get ammonia. Are you clear? What is the flow chart? Only the flow chart. You have to practice. By saying it is very easy to see. So you have to practice again and again. So you have 3 marks question you have to answer within 5 minutes. You are going to take or to draw flow chart for 10 minutes. How can you answer all the questions? So you have to repeatedly practice. Then easily you can draw this diagram within 2 minutes. Only a flow chart. Okay, I will explain again. So this is compressed in a compressor. And then this gas is passed in a catalytic chamber where the actual reaction takes place. Temperature is 700 Kelvin and the catalyst is iron oxide and the promoter is potassium oxide and aluminum oxide. And however, the water ammonia is condensed and we get liquid ammonia. And unreacted gas is going to pass in a recycle. See, preparation of ammonia, it is a very costlier one. Economically, again we have to take, we have to use better to use in recycling. We have to recycle with unreacted gas and again pass, so continuously we get. So in the Haber process, nearly we get not more than 10 to 20% ammonia, and this much we have to remember. Are you clear? Okay. For small disturbance at the beginning, 5 to 10 minutes. And slowly I delivered the syllabus. According to your annual examination, preparation of ammonia is very important. And draw again and again the flow chart and write the equation and remember the drastic condition. Okay? Or due to heavy rain, we don't know all the students are having accessibility of network. If suppose you are not having the network, go to the network place to your neighbor or anywhere, just download it and see again and again. Are you clear? Okay. Any doubt regarding your internet accessibility or regarding the topic, just you can message and shortly we will send you the notes. Okay, thank you.